Hello, today we are going to be making a procedural gear in Blender using geometry nodes. To begin with, we're going to select our default cube and let's enter geometry mode to delete everything in it because we just need an empty mesh. Technically, we don't actually need to do this, but I don't like having geometry in my mesh that I'm not going to use. Let's change the name of our cube to something like Procedural Gear. And to actually add the geometry nodes modifier, we're going to go down to our modifiers tab, add modifier, and choose geometry node. Now, if we want to actually view our geometry nodes editor, we need another window. So let's just drag one up from here, and I'm going to choose geometry nodes editor. And whatever we name this is going to be what we have to make sure shows up here. So I want to make this something distinct. So I'm going to call this GN Procedural Gear. That way I just have a very distinct name and I know that I am in fact working in this geometry node. So if you don't know what geometry nodes are, they are a way of making procedural geometry in Blender. You could do a lot of stuff before with the old modifiers, but nowhere near the amount of stuff you could do with geometry nodes. So for example, if I were to do Shift A, add a cylinder, and stick that in there, you'll see now we have a cylinder that shows up, and you might think, okay, great, okay, we have a cylinder, and I could just do that before. But with this, you can change at runtime how many sides and stuff we have. So that's incredibly useful, especially if you're trying to make something like a procedural gear. So how are we going to make this gear? Well, let's start by talking about how we would make it if we were to make it in a normal way. So let's move this aside. We're going to add a new cylinder and let's go into edit mode. So I suppose what a normal person would do when they're trying to create a gear is, well, first off, they would try to make it smaller, I'm guessing. Let's bring that down a bit. And then they would select every other side on the side. So let's do like that. Now that we have all the sides selected, we would have to extrude all the faces. So let's do a extrude along normals. And then I suppose you would have to cut a hole in the middle. So let's take the top and take the side and let's inset that. And then just bridge those faces. And voila, we have ourselves a little gear. That is fine, I guess, except now you can't change anything about it. If you wanted to, well, you could change some things. You can change the height and the width and stuff. But if you wanted to change how many spokes there were, you can't do that very easily. So let's go to our procedural model instead and try to do the same thing. So first off, the depth is going to be how high this is. So let's expose that first because that's just incredibly easy to do. So to do that is relatively simple. We're just going to go down to our panel here on the right of our geometry nodes editor where it says group. Under input, we're going to hit the plus sign and that's going to give us a new input. You'll notice now that under group input, this now appears over here. We're going to keep this as a float. We're going to change the name to height. And at the moment, the default is 0.000 and the minimum is negative infinity. You can't really have a negative height, so I want to change the minimum at the very least to be 0.01. And I'm also going to set that to be our default. And you'll notice that the number has not changed over here. If you just move the slider in any direction, it will update. And now I can no longer slide this below 0.001. So if we were to connect our height to our depth over here, you can now see that our height has changed for this gear. And if we change it in our tab, it now also changes in our geometry. That's exactly what we want. While we are here, let's add another input for our spokes number. I do not like the fact that you can have multiple inputs with the same name. I wish they would change that, but it's easy enough to just fix yourself. We'll call this spokes number. And this is not going to be a float. You can't have like 2.5 spokes. So let's change this to an integer. That is a whole number. Minimum, again, we're going to change to something that is not ridiculous. Let's go with 3. And a maximum, I don't really care. But let's go with like 128. I don't really see all that many gears that have more than that. There we go, we're now clamped between 3 and 128. Now, we can't just directly connect this spokes number to our vertices. I mean, we technically can, and it will change how many sides the gear has. However, that doesn't really work because you may have noticed that we need twice as many sides as we have the number of spokes. So we can fix this quite easily by just doing some math on this. Let's drag off of here. We're going to do a multiply, change this value to 2, and then drag that into our vertices instead. And now you'll see that we have 6 sides, and our spokes number is 3, and if we increase this to 4, we now have 8 sides, and 5 will have 10, etc. So that will give us the exact number of spokes that we need, depending on how many spokes we want. Now, to actually extrude the sides of our gear, let's move this out of the way slightly. We don't need to look at this for a little bit. We will have to look at it later. You'll notice that on the cylinder node, we have a lot of other outputs besides our mesh. We have our top, sides, and bottom. These are used for selecting different parts of the mesh. For example, sometimes you might want to do stuff only to the side or only to the bottom of whatever these nodes are. There are other nodes that have these. If you do an extrude, for example, extrude mesh, you'll see that we have a top and a side extrude. And if you just plug in the extrude between the cylinder and the geometry output directly, you'll notice that it extruded every single side, which is not what we want. We only want it on the sides. Luckily for the extrude mesh, we do have a selection input, so let's select our side. And now it only extrudes the side faces, but again, that is not what we want because it is extruding all of our sides. We only want every other one. So how are we going to only select every other one? Well, when the geometry is created, or rather when a geometry exists in general, these faces aren't just there arbitrarily. Every single one has a face number. And when a cylinder is created, the top and the bottom faces get a number, and then all the side faces get a number as well. Let's get rid of this so I can accurately talk about this. The top and the bottom has a face. In Houdini, that is like 0 and 1 on the top and the bottom. I'm not sure about how Blender does it, but I do know that Blender does do what Houdini does, and that is every face along the side is sequential. So let's say this was number 3, this one would be 4, this will be 5, 6, 7, etc. And if every face next to each other is sequential in number, that means all we have to do is do some simple math again to figure out if we should select that. So let's add a math node, and what we want is the modulo. Now what the modulo does is it divides the first value by the second value, and it gives you back the remainder. If we set the second value to 2, to a constant of 2, every other number will be a 0 or a 1. It'll go in that order. So if you do 2 divided by 2, that is 1, and it has a remainder of 0. If you do 3 divided by 2, you get 1.5, but if you just look at the whole numbers and the remainder, what you have is 1 with a remainder of 1. 4 divided by 2 is 2 with a remainder of 0. If we just care about the remainder, which we do, with a modulo, that means we get 0, 1, 0, 1, etc. over and over. Now, what are we going to modulate? Well, you can get the index of the side, that is this number right here. The index is just going to be a number. And what this node does is it basically goes through all the faces and returns you the index for this face. So if we take the index, modulate it by 2, and then see if it is equal to 0, we're going to use a integer comparison because it's going to return an integer. There we go. And we plug that into our selection in our extrude mesh, and then we plug our extrude mesh into our geometry output. You will now see that every other face is extruded. Now, this is also extruding the top face, which we do not want, but we can get rid of that because, again, we have access to our top, sides, and bottoms. We only want this to be the side one. Now, you might have noticed that this equal returns a pink diamond, and that is a Boolean value. What these diamonds are, these are just Booleans. If you don't know, a Boolean is just a binary value. It can either be true or false, yes or no, 1 or 0, etc. So what it's saying is that when you go through the selection, if it's a top face, then it will say true. And if it's not one of the top faces, then this will say false. And when the operation looks at the selection you're doing, it just goes through all the faces and it says, okay, I selected, for example, let's say I did this. Let's make it easier to see by doing that. This extrude mesh will look at our selection. It goes over here and it says, okay, go through each of the faces, and if this side output returns true, then that is going to be part of our selection when we extrude this. Right now we're using this modulo to determine if we are going to extrude it or not. I want it to be true if both it is a side and this result is true. So off this, I'm going to drag this, I'm going to say and. I'm going to connect both of these to the Boolean and plug this into this selection. And voila, we no longer have this top face selected because it will only select the face if it is a side, and if that side's index modulated by 2 is equal to 0. In other words, it's going to select every other face on the side. And if we change the number of sides, you'll see that this still works. No matter how many sides we have, everything works perfectly. Well, these spokes are a little long. We can change how far out they go by changing this offset scale, but again, let's just make that a parameter. So let's add a plus over here. We're going to change this from spokes number to be spokes length. And we're going to change it from an integer to a float. Going to change the minimum to be 0.001 and the default to be 0.001. Let's move this around to update that, and then we can drag the spokes length to our offset. That is actually incredibly short. I did not expect it to be so small, but there we go. Now we can change it from in here without having to touch the geometry nodes editor. Now we are going to have to cut a hole in the middle of this mesh. So let's deal with that. Move this stuff out of the way. Don't care about any of this stuff at the moment. How are we going to do that? Well, again, last time what we did with our cylinder over here was we just selected the top faces, we inset them, and then we bridged them. So let's try to do that the same way here. We're going to select our top faces from not our extrude mesh, but from our cylinder. This selection will still only select the top meshes. So we have it selected. Now we need to inset it. Unfortunately, as of Blender 3.1.0, there is no inset node. But insetting a circle is incredibly easy because it is exactly the same as scaling it down. And what we do have is a scale node. So let's add a scale selection. Let's plug this mesh into here, plug that into there. And we can't actually see anything happening. Actually, we can. Oh, right, of course. I forgot to mention the fact that we actually have to create new geometry because the side is being selected, but we're just scaling that side down. So obviously it's just going to bring that side in. First, we have to create some new geometry on top of that side, and then we can scale that geometry down. So let's do another extrude mesh. And this time for the selection, we're going to choose our top and our bottom. We want both of these to be extruded because we want the top and the bottom to both be inset. So let's do a top, do a OR this time, Boolean OR, into here and here, plug that into our selection, and you'll now see that our top and the bottom are being selected. And instead of offsetting it at all, we're going to offset it by 0. So these, it doesn't look like anything's happening here, but there are now two faces directly on top of each other, on the top and the bottom of this. You just can't see it because it's overlapping. Let's actually turn on wireframe so you can actually see the geometry. Yeah, so you can't see any of this, but it is there. Now that we have those selected, what we're going to do is we're going to extrude the mesh of the top side of this extrude, not the top of this scale. And now you will see our geometry being inset. If I go back to our shaded view, you won't actually see anything unless I go over 1, but don't do that. And you will, yeah, you will see the geometry if we enter wireframe mode. The reason we're choosing the, where is it? The reason we're choosing the top of this extrude mesh is because that's what we are trying to select. When you do an extrude operation, the top, let's use the side faces for example, the top is what face got pushed out. So the top of this extrude mesh where we pushed out the spokes is these faces on the side, right here, here, etc. And the side faces are these faces on the side. we're not going to do anything with those, but I just thought I should let you know why we are using the top instead of the side or whatever for this extrude mesh. So now let's set up the input for how wide we're going to make this circle. And in order to do that, we're going to have to set up another parameter, which we really should have done first, and that is the radius of the entire gear extruding the spokes. So let's add a plus. We're going to call this our radius. Default, let's make it 0. I don't know what we're at right now. Let's go with 0.1. And the minimum will be 0.001 again. Let's move that around. And I'm going to set this to be 1 because I believe that's what we are at the moment. If we go back to our cylinder, you will see our radius is at 1 meters. Yes, so let's plug this radius into our radius. Nothing has changed until we start moving this around. Now you'll notice that as we move this around, the size of the circle also changes as well. And that's because when we are scaling it, we are doing it based off just a scale. So obviously the bigger that the radius of the original cylinder is, the bigger the hole will be, and vice versa. And that is why we need to set up the radius first, because we're just gonna have to do some math to figure out how wide the hole should be. So let's add another parameter. We're gonna call this our hole radius. What is the minimum of this one? 0.01. Let's make that 0.0005, I guess. That's gonna be like half. Oh, will it not let me do that? Oh, okay, it just shows up as 0.01. And we're gonna make the same thing for that, 0.005 or whatever. Well, it shows up as the correct number, so I'm gonna assume it's working correctly. And the issue now is figuring out what the scale needs to be in order for the radius of this hole to be equal to this. And that is going to require us to do some simple math. So I know how big our radius is, and I know how big I want this radius to be of the inner circle. Let's call this radius R, and let's call the radius of the inner circle something like R1 or whatever. And what I need to find out is X. X is going to be the scale. Forgive me for this lopsided writing. This is how I write normally. I just tilt my paper, and that's why my writing is never lopsided, but I can't very easily tilt a drawing tablet, so yeah. Well, what's currently happening is we're getting the R. Oh, actually, this is a terrible idea calling this X, because times is an X. So let's call this S. Okay, R times S is going to end up giving us our R1. So the solution is pretty simple. We have R times S equals R1. If we just divide both sides by R, then what we end up with is S equals R1 divided by R. So let's try that and see how that works. Back in Blender, we have our R1, which is our, where is it? Hole radius, and we have our radius. So let's drag off from here, do a divide. And we're going to drag our radius into our value and plug that into our scale. I believe this did work. If we change our hole radius and we move it up, you'll see now it works. Cool. If we change it to 1, everything matches up. The hole radius is now the same size as our gear. And then if we change it to, say, 0.5, it is now halfway in the center. Great. And if we were to change our radius, the whole radius stays exactly the same. Exactly what we want. So how do we go about bridging these two faces? Well, unfortunately, again, there is no bridge operation. If we were to do bridge, it doesn't pop up because that does not currently exist in Blender 3.1.0. If it does occur sometime in the future, feel free to use that. But it's not in this version, so we're going to have to get a little creative when we're doing this. What is a bridge operation? Basically what it does is it takes the top face and the bottom face of whatever you're bridging, and it just deletes them, and then it creates the faces in between. Well, we can do that. We can do that pretty easily, actually. So let's go back to our wireframe. We have the top and the bottom faces. That's just what this top one is here. That's what we scaled in. So if we just do a delete, geometry, and we plug this into here. Plug that into the output. You will see that everything disappeared. Why did that happen? That is because we are currently deleting the points. And if we delete the points of here, let me drag this back over here. If we delete these points in the middle, that's going to make it so that these faces on the side can't exist. So let's not use point. Let's instead choose face. And voila. If we go to our shaded view, you will now see that there is a hole in the center. Now all we have to do is create the faces on the side. So now we have the top and the bottom faces deleted, and what you normally would do again is you would just bridge the sides, honestly, if you wanted to create the sides in this situation, but unfortunately, there is no bridge. So instead of deleting both the top and the bottom, what we're going to do is we are going to delete just a top or the bottom face. And then we're going to extrude that face up or down to where the old face was. Then we can delete the face. Then we can merge the vertices by distance so that there's no overlapping vertices, and we can just, have a solid closed mesh, and it should be good. So how are we going to do that? Well, at the moment, what we're doing is our delete geometry is deleting by this extrude mesh's top sides. We still need to do that because this top sides are the faces that we inset, and we still need to inset those faces. So based off how we selected the side faces earlier, we can just add another logical thing to it. So we're still going to choose the top. We're just going to do an and on top of that. And what are we going to use this and based off? Well, let's do it based off how the face is facing. The top face is obviously facing up, and the bottom face is obviously facing down. So let's choose our faces normals. Normal. And let's say if the normal is equal to -1. Let's do +1. 1. X, Y, Z. Sorry, this should be 1 over here. We plug that into there, and then plug this into our selection. Voila! We now have a top face that is deleted, and the bottom face is not. Excellent. We can now do another extrude on this top face of this extrude node. Again, that is not actually the top face, it is just the top face of what was extruded, which only leaves the bottom face now. Let's do an extrude. And you will now see it go, this bottom face is now being extruded down 1 unit, and that is because it is facing the bottom. I want this to be facing the top, so obviously we would want this to be a -1, let's say, for example. It's not actually going to be -1, but -1. And now we need to make it go exactly the distance it needs to be in order to hit the top of the face. Well, we can do that because we know exactly how high this is. This is based off the gear's height. So let's just drag all the way from here our height. Let's do a multiply by -1 and plug that into our offset for that extrude. And voila, that is now in the exact correct position it needs to be. Let's move this stuff over here slightly. And then we can now delete that face. Let's drag off here at the top. We're going to do a delete geometry. Plug this into here. Plug this into here. Change it from point to face. Plug that geometry into there. And we have ourselves a gear. Lovely. Again, these vertices aren't merged yet, so we have to do that. So let's do a merge by distance geometry and plug that into our geometry, and hopefully this will now be a closed mesh. And we have ourselves a basic gear. We can change the hole radius, we can change the radius, we can change the height, etc. Now you may have noticed that as I was dragging this radius around, you could see that the hole can actually become bigger than our actual radius itself, which is not great. So let's change that. When we define how big the hole is, that is based off this scale elements here, and that scale is simply based off dividing our hole radius by our radius. We want to clamp that by a value. So let's drag off here and do clamp value, and we're going to make the minimums, well, 0. But we want to make the maximum something like 0.95 or whatever. And then we're going to drag this into our scale, and now you'll notice that no matter how high I actually make this value, it won't go above a 95% scale. So this hole will never be bigger than 95% of what this hole is. If I were to now increase our radius up until a point, you will now see that the hole is exactly what it's set to until I lower our radius again. So that will, at the very least, make it so that our hole can't be below a certain threshold. That is a very small hole, but that hole is still there at the very least. So let's do something a little bit more interesting. Now that I have my basic shape, I want to make it look a little bit more like a gear. First off, this looks fine if you want a really blocky gear. If we were to change the spokes number to something like that or whatever, you know, now we have something more gear-like. You can just look at that and be like, oh yeah, that's a gear. But if we have a pretty low number, let's change it back to like, I don't know, 7, which is a strange number, but whatever. Everything's very blocky. And if you look at the spokes themselves, you'll notice that the gears are just being extruded straight out, which isn't really what gears do. If we look up images of gears, you'll see that it doesn't go straight out. It sort of, you know, is smaller at the end, and the holes at the beginning are also smaller. Like everything gets scaled on the sides basically to be sort of more pointy than it is just sort of straight, if that makes any sense. Hopefully you know what I'm talking about. What we want to do is we want to scale the sides of all of our side faces. So that's going to be all the faces over here from our original cylinder on the side in a specific way. Because let me show you what happens right now if we just try to scale these sides. If we do a scale elements, and let's do it, I don't know, like 0.8 or whatever. And we plug this using that initial selection into here. Everything gets scaled down on all axes because we're not doing it by a single axis. So first off, we need to do it by single axis, and second off, we need to not scale down every single side, because at the moment it's also scaling down the side faces on these gears right here, which we do not want to do. So we still need to scale the elements, we still need to do it after this geometry, but we're not going to use this selection. We're going to change it from uniform to single axis, and you'll see what happens now is that only on one axis, at the moment this is set to X, because we have it set to XYZ, this is X, and it's scaling in this way. Let's deal with our selection first before we deal with the axis. I'm still going to keep this at a number so we can see the effect of that scaling happening, just to confirm which faces are being scaled. But I do not... Wow, this is very disorienting to look at. So we know what we want to select. We just want to select this face, this face, this face, this face, this face, etc. Every other face, basically, on the side. Now, we've already done something selecting every other face, where we did the modulo, but we're not going to do that this time for a reason that I don't want to get into just yet. We're going to deal with that after this. So instead, let's take our side selection, and let's just remove some selections from it. Take our side from our cylinder, drag it over here, and for now, let's do a knot. That's not actually what we want to do, but I want to have something here to work with. Plug this Boolean into our selection, and that's kind of interesting, actually. It's not what we want, but it is interesting. So if we have our... Actually, and makes it so everything goes away. Let's work with this for now. We have a lot of different things we can select here as far as how to change our selection goes. So what I want to choose is this subtract. So right now I have the side selected, and what I want to do is get rid of all these sides that came as a result of this extrude. So let's do a subtract. Go back to where we did our extrude mesh. This is where we extracted our spokes, and choose the sides and plug that into our subtract. And now you will see that everything is being scaled except Well, you can see that all the sides are being scaled. Technically, all of these sides are also being affected, but not in the same way. These sides are being affected because these faces are changing on the x-axis. That's why these faces are changed. But just trust me when I say that they're not actually being scaled here. Now we have to change the axis of our scale. Because at the moment, everything is just being scaled along the x and it's being scaled by half. That's why everything is getting squished in this way when it comes to these faces, I mean. The axis is going to be sort of the direction that it's being scaled in. And funny thing about directions is that we know the directions of our faces. That's just what a normal is. So let's add a normal node. And what happens if we try to plug this into our axis? Well, nothing, basically. It looks kind of the same because we have to change our axis based on a normal. If we just do this, then nothing's going to happen because basically what it's trying to do is it's trying to scale it like, well, let's take this individual face, for example. What it's trying to do is it's trying to scale it like in this way, and that's not really what we want. That's kind of doesn't do anything because it's a flat face. It's a single flat face. It's not going to do anything. So off this normal, we're going to do a cross product. I don't want to explain what this is because I can't be bothered. We're just going to change the z to 1, plug that vector into our axis. And would you look at that? We have exactly what we want. These faces are now being scaled on their own axes, and it's working out perfectly. That's great. I love it. Okay. Let's just add another parameter then to set what this is going to be. The name is going to be ours. I mean, in my original example, I called it spoke scale. That does technically work as a name, but I wouldn't really recommend using it. I'm very bad at naming things though. That's why you know I'm a real programmer. I'm going to set the default to 0.01, set the minimum to 0.01, and I'm going to set the maximum to be 1 because sometimes you do actually just want to have like a flat, you know, thing, and plug that spoke scale into, give me a sec, plug that spoke scale into our scale. Here we go. And now we can change this over here. That's great. Sometimes you are looking for this look. So, you know, if that is what you're going for, then by all means go ahead. I just personally prefer something that's more like this. And then if we change the spokes, we can, yeah. I quite like this look. Anyways, there are 3 more issues I want to cover before ending this video, and they can be demonstrated if I reduce our spokes number down to something like 3. Let's not use 3, let's use 5. There we go, 5 looks good. And the issue being that 5 does not actually look good. This looks terrible. This looks incredibly low poly. Let's go 6. 6 is a pretty common number. This is incredibly low poly, and you can just sort of see every individual face. That's not great. Nothing about it looks rounded at all. It just looks like a very flat gear. And if that's what you're going for, then by all means, go ahead. But I want to add some more resolution to this gear. And by resolution, I don't mean subdividing it, because that would suck. Have fun trying to subdivide this while trying to keep the top and the bottom flat. And the sides for that matter. Because I still do want these side faces to be flat. Instead, what we can do is we can just increase the number of sides that we have on our gear. Let's go back to Photoshop for a second. And what we're doing right now is we're just ticking our gear, right? Let's say we have 6 faces. 1, 2, 3, 4, 5, 6. That's 8. And we're going, okay, well, here's a face, here's a face, here's a face, here's a face. And as a result, we only have very flat faces. But what if we did something like this, where we have 1, 2, 3, 4, 5, 6. This is absolutely terrible. Okay. But instead of going every other face and extruding that, what if we take every 2 faces? Right? Now, all of these external faces and internal faces for that matter, are cut in half. Like this. And we have a bit more resolution here that adds a bit of a curve to our geometry. And I didn't number this correctly. I don't have the right number of... Just ignore that. You get what I'm trying to say, okay? How we're going to do this is, well, first let's add another input. We're going to call this our resolution. We're going to make this an integer because we can only really have a resolution that is a positive number. We're going to make the minimum 1, the default 1, the maximum. I'm going to actually set a maximum here of like 4 because you're never really going to need more than 4. So let's start with that. First order of business is that we have to change the number of faces that we made when we made our cylinder at the very beginning. So let's set this to 3 as an example. And how we determine our current number of faces is we're just multiplying our number of spokes by 2. Well, now we need to multiply by 2 times our resolution. So we have the proper number of faces. So let's drag this off. Let's do another multiply. Drag this into here. Drag this into here. Drag that into there. That's already selected. Cool. Look, we can minimize these now. Drag that into our vertices. Great. We now have 3 times as many faces, and the problem now is that we now also have 3 times as many spokes. That's not what we want. So now we have to change how we extrude stuff when we do our extrusion for our spokes. If we go over to our extrude mesh, this selection is simply based off if it is a side and if the index modulo by 2 is equal to 0. Now this next step is actually incredibly simple, but I'm very bad at explaining it, so try to follow along with me for a second. I'm aware that I'm going to explain this very badly, and it might be hard to follow, but just bear with me for a second. We're going to take our index, we're going to divide this by our resolution. This divide is now going to plug into our modulo, and nothing works because for some reason when you do that, the modulo will automatically connect our previous thing that was connected to 1 into our slot 2, which I do not want to happen, so just disconnect that. And now we have this happening. You'll see what happens is we have 3 faces that are not extruded, then 3 faces that are extruded, 3 faces that are not extruded, 3 faces that are extruded, etc., etc. And, well, we don't want these to be extruded individually. So in our extrude mesh, we'll just turn off individual, and voila, we now have some resolution to our mesh. Well, this looks very bad where the sides are still circular, pointing outwards. We will fix that in a moment after I explain what just happened. So if we go back to Photoshop, let's list a couple of numbers. Let's do 3, 4, 5, 6, 7, 8, 9. I think that should work. What's happening is we're dividing all of these by, this is the index. And if we divide all of these by 3, what we get is 1. And then 4 divided by 3 is going to be 1 point something something, but these are integers. And in math, what happens when you divide an integer by an integer, or in programming math at the very least, when you divide an integer by an integer, what happens if you only get the integer with no remainder? So 4 dot 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 is just going to be 4. 5 divided by 3 is going to be 1 dot 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 divided by whatever, remainder of 2. 6 divided by 3 is going to be 2. 7 divided by 3 is going to be 2 with a remainder of 1. 8 is going to be 2 with a remainder of 2, but again, we don't care because all we get is that integer. And then 9 divided by 3 is going to be 3. And then at this point, when we do the modulo by 2, what we get is basically what we had before, where we're going to get a sequential number of numbers where it's going to be 0 or 1. So 1 modulo 2 is going to be 0, 0, 0. Oh, no. This is going to be 1. 1, 1, 1. 2 divided by 2 is going to be 0 for remainder of 0. So this is going to be 0, 0, 0, 1, 1, 1, 0, 0, 0, etc. So that's how we can get our gear to extrude every 3 faces instead of every 1 face. So we want to have a resolution of 2. Voila, now every 2 faces are extruded. If we want 4, every 4 faces are now extruded, and honestly, you don't need more than 4, which is why I kept it at 4, because the minimum you're going to have is like 3, and even then, 4 looks fine. I mean, if you want to have more than 4, go ahead, but I personally think 4 is sufficient. Okay. Now let's fix the issue that I mentioned earlier where these faces are still extruding out, and that looks terrible because it should be sort of in, not out. To do that, all we're going to do is scale these faces in by a negative direction. So you can probably see where this is going to go. We're going to go back to our subtract option here. This is where we selected all of our faces except for these side faces here. That's what this selection is. Now all we have to do is also just remove these side faces on the side. So, easy enough. Take this Boolean, do another subtract, Boolean math subtract, and I want to subtract the front of this extrude. I believe that was this top one, yes. Subtract that, and then do a scale. Again, we want to change it from uniform to single axis. We're going to plug this into here, plug that into there. Change the scale just to prove that it is selecting the right stuff. And the axis we want to, well, we want to change the scale to -1. -1. And the axis is going to be our, well, it's going to be based off our normal again. So off our normal, we're going to do another well, can we just plug in our normal axis? Yes, we can. Okay, so we can just plug in our normal here because that is the direction the face is facing. So we just want to, whatever it's facing, scale it -1, and bam, we have this nice rounded gear. Excellent, exactly what I want. If I change the spoke scale some, this looks very awkward. Like once you get to a certain point, it's like, that does not look great. So don't get to that point, basically. Optionally, you can change this into 2 different selections where you scale this inner part in by a different amount than this outer part. But I'm lazy and I would rather just have one control, and it looks fine, so I'm just going to do this. Now that brings us to another problem. So let's change our spokes number to, like, say 12. That's a reasonable number. At this resolution, I might still want to have a resolution of, say, 4 on each of these sides. However, you'll notice that this interface has a ton of geometry. If we look at this part right here, you'll see, look at how much geometry we have for this simple little gear. We don't need that much, honestly. And if we were to change this down to 6, again, another pretty, don't keyframe that, another very common number, and we have a resolution of 1 because that's all we want. In this particular case, we just want a resolution of 1. You'll notice that the inside is very blocky. We can see that, and that is not great either. I want that to be a nice smooth circle, regardless of the fact that I want the outside to be a very, how should I say it, blocky shape. So in this particular case, I want to have a high resolution hole in the center with this low res thing on the outside. Let's deal with that. I am going to add a new input. I'm going to call this alt center hole. The type is going to be a Boolean. Here we go, Boolean. The default value is going to be false, and in this, that's weird. It does not appear to be showing up here. Oh, actually it is here. It's just that instead of showing up as a check mark, it is a 0 or a 1, which is not very convenient. Why would you possibly do that? Please make it a checkbox. But 0 is going to be false, true is going to be 1. For now, I'm going to set that to be true. And what I'm going to do is I am going to drag off of this scale element and do a switch. Output. Now what this switch is it's going to say, okay, we have an output. What are we going to put into this input? If this Boolean value here is true, we're going to send a true value. If it is false, we're going to send a false value. So if this alt center hole is false, we're going to do what we've been doing. We're going to plug it in from here, choose our alt center hole, plug that into our switch. And now if we change this to 1, voila. the geometry disappears because we are plugging nothing into it while it is true. So for the true part of this switch, I want to connect for now the extrude mesh right after we extruded our spokes. And now you'll see that if we change our spoke scale, everything still works. And if we change the resolution, everything, again, still works. So how are we going to cut this hole if we're not going to just inset the faces and bridge them, basically? Well, we're going to do it the traditional way of cutting holes, and that is by using Booleans. You can't do that still in geometry nodes. If we drag off this true, let's do a Boolean. Our mesh 1 is going to be that original mesh that we had dragged in there earlier, our extrude mesh. And our mesh 2 is going to be a cylinder. Cylinder. There we go. And now you will see that it entirely disappeared. Ignore that fact for now because that is just due to our radius being way too high. Let's drag our hole radius into there. Hole radius into here. And you'll see that the hole is being cut. Oh, that is because like my hole radius is currently set to higher than my actual radius. My bad. I'm very silly for having kept that there. Again, then we should probably cap that by the amount that we did over here, where we did our divide and our clamp. We're just going to clamp it by 90% of our radius. So let's drag off our radius. Let's do a multiply. Value is going to be 0.9. And off this value, we're going to do a clamp, hole radius clamp. And the minimum is going to be 0. The max is going to be this multiply. Drag this into our cylinder's radius. And then, yes, now it can no longer go above that value. Excellent. We changed the alt hole to be... Did I set the other window to be 95%? I did. Okay, let's just keep that consistent. Clamp is going to be 95%. 0.95. There we go. Now it's consistent. So now we can set a new parameter. Let's go with alt center hole radius. No, not radius. Resolution. Resolution. I can type, I swear. It's not going to be a Boolean, it's going to be a integer. This is just going to be how many sides the center is going to be. We're going to set this to be a default of, say, 6. Minimum is going to be 3. I don't care what the maximum is going to be. And then plug that into our vertices. Down here. You now see we have a 3-sided hole in our gear. If you want to do that, then by all means go ahead, but that's not the point. That wasn't really the example we were doing. So the example I wanted was I wanted a nice resolution hole in the center over here. So let's change that from 3 to like, I don't know, 16 or 24. And that's a nice round hole in the center of our very blocky cylinder or gear. And if we want, we can turn it on or off. Excellent. And everything does still work. There is one issue though, if we were to change our height to be greater than 1, or greater than 2, our Boolean no longer works because the cylinder that was created in this geometry node for this mesh Boolean, it's just set to a simple depth of 2. So let's change that. Pretty simple to do. We're just going to take our height. We're going to do an add. Here we go, do an add. Let's just add like it doesn't matter what value you do, honestly. Plug that into our depth. And now it will cut the hole no matter how high we make our height. As long as the height is greater than our height of our cylinder, which it always will be thanks to our add, it's fine. Now this brings us to our third and final problem, and that is that this is not very reusable at the moment. I mean, what you can do is you can, duplicate this if you do Shift D, you can move this around, and then now you have a separate instance. You can change, whatever you want about this instance. And that's great and all, but you will still need this file in order to reuse this node graph. If you want to reuse this gear in multiple scenes, you'd have to either recreate the entire graph, which is not convenient to do. You might have been able to tell from the length of this video. Or you'd have to start a new scene with this graph in it, and that would just be a pain. Fortunately, as of Blender 3.0, there's a thing called the asset browser, which you can use to save presets for objects and stuff like that. So let's just save this as a asset in our asset browser. So to turn this into an asset is simple enough. All we have to do is right-click over here and mark this as an asset. And if we were to change this from a geometry node editor to a asset browser, and we refresh that over and over again, I guess, you will see in our current file, we have our procedural gear. If we drag this out into here, we have another procedural gear. We can change stuff about that, and that's great. That's not that great, though, if we want to use this for other projects. So let's save this file. We do have to save this. So if we were to open up a new version of Blender and we were to drag this up and create a new asset browser, you'll notice that the gear is not there. That is because we have to change it from current file to user library, and then the gear shows up. We can put it wherever we want, and we can change whatever we want about it. If we go to our modifiers, change the height, change the spokes number, change the custom thing, resolution, whatever, etc. All that good stuff. Now, it should be noted that you might not actually be able to see this at first if you don't have your Blender stuff set up properly and everything saved in the correct location. If you go to Edit, Preferences, and go to File Paths, you'll see something called Asset Libraries User Library, and this is the default one that is sort of there by default. I already have a folder in here called Procedural Gears where I saved my Procedural Gears blend files. You need to save your stuff either inside of this folder, the Blender/assets. If that folder's not there, you can just create it, or you have to create a new directory for you to save your stuff in. Now, at the moment, I don't like how this is set up where it's just under user library, it's under all, so let's change that. I'm going to close this file. And in this all, I'm going to hit the plus sign. I'm going to make a new catalog. This is just a folder, basically. I'm going to call this Procedural Gears. And nothing's in it right now. If I go back to my all, I can drag this into my procedural gears, and in the procedural gears, you'll see that that is now there. If I hit save and I open up a new Blender, do what I just did earlier, go to my asset browser, change it from current file to user library, you'll now see that the procedural gear is now listed under procedural gears, which is much better in my opinion. This is also particularly handy if you want to, say, for example, create presets. So I want to have a preset for, say, 32 spokes. I want to have one for 16. And I'm just going to select both of these, select these and mark as asset in the all, drag these into procedural gears. And if I save my scene, go back to yet another new Blender file, change this to asset browser, go to user library, procedural gears, you'll now see we have our different presets as well. So you don't have to, make a different gear every time you want. You're not just limited to a single instance of this gear. You can set up whatever preset you want as well. And also, if you need something changed, just change it. You probably don't want your spokes to be that length, but you get the point. Anyways, that has been how you can create reusable procedural gears in Blender using geometry nodes. I will leave a link to this in the description if you want to go just download it instead of doing the work for yourself. I completely understand. And if you somehow made it this far, thanks for watching. I really do appreciate it. You may have noticed that I haven't been really making any videos lately, and by lately I do mean in the last 3 years. So it would be tremendously helpful if you would leave a like, comment, and consider subscribing if you found this particularly useful. I don't normally beg for those things at the end of YouTube videos, and by normally I mean this is my first time doing it as far as I know, but if I could make YouTube videos for the rest of my life instead of working dead-end jobs, that would be awesome. So anything to help the YouTube algorithm at this point. With that out of the way, I will see you next time, hopefully. Goodbye.